Zasowski here, coming to you from C209 at the high school. I'm going to be using this piece of equipment to do some demonstrations with energy. So I have a pendulum, basically a mass attached to a string for me to swing back and forth. And normally I would have a student help me demonstrate this, but I'm going to be doing it myself. And so I'm going to stand over here with my back to the cabinet, with my head up against the cabinet. I'm going to take this mass, I'm going to lift it against gravity, and hold it right up here, touching my head. Usually this works a little better with a taller student. Usually it's touching their face, but anyway, I'm going to release it from rest, and let's see what happens. Now, what's so important is that I release it from rest, and that I don't move. You'll notice I'm going to keep my eye on the ball. Let's see what happens. So you can see that even on the first swing, it looks like it's going to come back and hit me. From my perspective, it really looked like it was going to come back and hit me, but I didn't flinch because I believed in physics, I believed in the law of conservation of energy. But from your perspective, you saw even on the first swing, it didn't quite reach the height of my head. And with each successive swing, it definitely is going less and less high towards my face. So at all points, I was perfectly safe as long as I released it from rest. Now let's consider what's going on here. Normally, when we talk about a pendulum, we think about conservation of energy, but anytime we talk about conservation of energy, we have to consider all the forces involved. So let's consider all the forces on the pendulum bob here. Well, of course, we have the force of gravity pointing straight down. What sort of force is that? Of course, it's a conservative force, and if that's all that was there, it would be just fine. But there's other forces as well. For example, there's a string, so there's going to be a tension force. Now, tension is not a conservative force, and so we shouldn't expect conservation of energy because there's a non-conservative force doing work on the system. Or is it? Let's think about the equation for work. It's F delta x cosine theta, where theta, of course, is always measured between the force and the motion. We know strings only pull, which means the tension force is always directed along the string. And so at all points, the tension is always at right angles to the motion. And so if it's always at right angles, theta is always 90 degrees, cosine 90 is 0, and so the tension, being a non-conservative force, is there, but it's not doing any work. And so we're right back to conservation of energy. And yet, of course, we saw we didn't really have conservation of energy. It never really got back up to the height of my head, and it kept losing height, losing energy through every successive swing. So what other forces are acting on here? Well, probably some of you said air resistance, because of course this is the real world. As the pendulum bob swings back and forth, it pushes on the air pushes back, and the air resistance is a non-conservative force taking energy out of the system. There's one more non-conservative force. Yes, it's friction all the way up there at the connection point. Every single time it swings back and forth, the metal support is rubbing up against the support on the ceiling, causing a friction force, again, a non-conservative force taking energy out of the system.